something, you're actually inferring it back and saying whether it's right or wrong. And then the network adjusts itself, and the next time you show it, it adjusts a little bit more. And overall, it goes through a long process of this training, and then to figure out, okay, now I'm really, it's like, you know, so we're giving, it's like a feedback loop, right? And then once that network is ready to go, you just put it out there. That's what. So this one is the video activity detection. Okay? Another example of inference is the image classification, what I was talking about there. So the network that we trained there is actually getting implemented. So it's going at a rate of like a large number of images per second, and it detects each and every image, what is going on in that, what object is there in that image. So you can't see this here, but you know, if you look at it, it's got a database of 10,000 images. It's sending it through a loop, the same 10,000 images, and at some rate, it is actually like, you know, detecting what is in the picture. In categories, there are like 1,000 categories that it detects, because that is what it is trained for. And search. You want to go for? So that is also another Vega 20 demo that Serge will cover.
That's right. Yep. We can talk about it in more detail, but essentially, so what we're trying to show here is machine-based denoising. So our radon per render path tracer, you know, naturally produces a certain level of noise, and so what we're trying to do with the denoiser is within the same amount of time to try to drastically reduce the amount of noise using machine learning, as opposed to just using the brute force approach, which obviously we still can do, but you know, so it's an option. It's out there. You can let the path tracer just resolve naturally, or you can use the faster path, which is supposed to eliminate a lot of the noise. And again, it's based on our machine learning stack. Side-by-side comparison, right? Yeah, that's right. And side-by-side comparison here with 50 samples. On the left, you see it's still very noisy. On the right, it's definitely much less noisy within the same amount of time using the machine learning-based denoiser.
Why is the noise created in the first place? Because if I understand correctly, this is ray tracing, right?
That's right.
Because the number of rays cast is too low, and the noise is introduced because of that.
Yeah, so obviously ray tracing is a family of algorithms, and what we're using path tracing. So essentially, we don't have a max number of rays we cast, so we can cast an unlimited number of rays. The problem with that, obviously, is so it's a Monte Carlo based integrator, and the problem with that is as you integrate, initially when you have a few number of samples, then that's going to generate noise because of the high frequency difference between the samples you get, and the more of them you have, then the more resolved it becomes. So to answer your question, the noise comes from the fact that it's just a normal Monte Carlo based path tracing integrator, and noise is it comes as part of the territory. Yep, yeah, we'll be able to play around with the demo. I just want to make sure that I guess they're more. Hey Shiva, were you done with all these other demos, or?
Yeah, so there are a couple of servers that were on display there. Those are the ones that. So these are the actual systems that you can buy in the market, like where it supports our Radeon Instinct products. And one is a system from Box, which is the 8 GPU system, and the other one is a box from AMAX, which is a 4 GPU system. All for data center on the cloud, running different workloads from machine learning, virtualization, cloud gaming, and also HPC applications. So I can show you. You see a plate on top. So this is the XGMI link. And this enables GPU peer-to-peer communications, which is very, very critical for machine learning workloads, where after every iteration you actually do a sync across GPUs. So that one is for this.
So you're just going to 4 maximum?
So maximum of 4. Okay. We also have X2 for 2, but X4 is the maximum.
And if you have 8, you put 4 and 4.
Yeah, so that depends on the topology of the servers. You've got to have these GPUs next to each other for this to be there. So for now it's X4.
And it's 100 gigabyte in each direction.
We're not speccing it out yet. So.
Okay, because it was shown 100 gigabyte this morning, but there wasn't any explanation if it was in both direction or not.
Right. Okay. I'm not sure. Okay. Yeah, like that. There's one attached to the board also if you want to take that shot. But it's probably part of the presentation. Sure.
Okay, so where's next? Over there, or?
Yes.
You're welcome just to walk around wherever you like.
Glenn Matthews said that it would work.
So what are you showing us here?
So here we're just talking about Epic for high performance computing. So we've got a example of a high performance computing server there. This is 4 gigabytes. It's 4 2-processor servers in a 2U enclosure. From a sidebar standpoint, showing off the growing ecosystem of HPC optimized servers. So we've recently been able to bring to market with our partners Cray, a new server offering from them, as well as with Cisco. And so that now brings our ecosystem up to 17 OEMs that are providing Epic-based servers. Those servers are providing superior price performance, whether you look at the entry price points or the highest performance price points across the full product stack. We're providing a better price performance of the competition. And that's resulting in us winning HPC opportunities across a number of verticals within HPC. So we recently announced that NERSC is using a Cray-based system using AMD Epic, so for large government research opportunities, as well as within HPC in the cloud. We recently announced the Oracle Cloud offering, as well as Microsoft Azure. Their HPC instances are based on Epic, and then also using lots of universities are using Epic-based systems. So the University of Notre Dame, as well as several other universities using Epic-based systems. So the momentum continues to grow for the Epic-based platforms.
Thank you.
My pleasure.
So for everyone watching on the live stream, I'm not able to, I haven't got my computer open to answer any questions, but I'm just going to different sessions and a little demo area and just asking questions and letting you guys have a look.
This is the solution I was talking about from the standpoint of
So there's some more demo areas. I'll just keep on keeping on.
And finally, we have secure encrypted virtualization. So with this, if you spin up a hypervisor, well, if you look at today's environment, right, the administrator and the hypervisor, they can go peer into every VM, they can go scrape memory, they can go take data out of each one of those VMs, right? So, or if you fall victim to an external attack on those VMs, the attacker can then potentially jump into other VMs or even into the hypervisor and compromise the entire system, right? So with secure encrypted virtualization, when you boot up the hypervisor, it gets its own unique encryption key. So everything gets encrypted in main memory for the hypervisor. And then as you spin up each individual VM, each of those VMs gets their own unique key. So now you've got cryptographic isolation between the hypervisor and between all the VMs. So now the administrator can no longer go see what's going on.
I'll ask him to start again in a moment.
It's encrypted with a key that he does not own and does not have access to, and then each of the VMs is also protected as well. In the event that you get hacked from an external source, one of those VMs falls victim to like a phishing attack or something like that, they cannot break out and go see what's in the other VMs or into the hypervisor because each of those VMs has a different key, which again they're not going to have access to. So it protects you in multiple ways.
Let's put the same on the previous generation with the new generation Epic, because now you have all the memory controllers in one place, one die, and also I would assume that there's no longer need to have four separate security processors for each.
So for today, right, you still only have a single security processor, right? And that security processor, what it does is it issues and manages the keys that it sends out there, right? So you look at it today with Naples, we've got the 4 different die. On each of those die, you've got 2 memory channels and then 32 PCIe lanes, right? And each of those memory channels, you've got a controller on there, a memory controller, and in that memory controller you have that AES 128 encryption in. So what we're doing with Rome, so now you've got the chips on the outside, you go to a single I/O die. You're basically on that I/O die. I'm now going to have the 8 memory channels and the individual controllers on each one of those on a single die, instead of having them across 4 different. So it's the same idea. You're just consolidating it into a single die. Right. The other thing I forgot to mention too is that other solutions that are in the market from our competitors are software-based, right? And so you have to go change applications in order to go make those work. What's unique about our solution is it's all hardware-based. No changes to applications are required. So you can go take legacy applications, new applications, whatever. They're all going to work without the need for the altered to run on the Epic platform.
I believe that on Intel platforms, at least part of the security system resides inside chipset, which is connected by some sort of link. And in your solution, all the security system and all the cryptography and keys live inside the CPU socket. So how does that work with out-of-socket communication to I/O space?
So for AMD, right? So we're only dealing with the encryption of the memory space, right? So again, when you issue the keys, those go to the memory controller, and we use those keys, those unique keys, to encrypt that space. I can't speak to Intel's architecture, but what I do understand, you're talking like with their STX system, or XEX security. So what they're doing there, that's actually an x86 instruction set, right? And you have to go write your code to that instruction set in order to go do that. And what they're doing is they're encrypting an enclave of memory. So it's not the entire memory space, it's just the enclave, and it's specific to the application. And again, the application has to be written in order to take advantage of that. And again, we're taking a completely different approach where it's like, look, you don't have to go mess with the applications. We enable the ecosystem and the hardware to go do that. So you don't have to change any of your applications to take advantage of the security.
So the advantage would be that I only have to modify the hypervisor.
Correct.
But on the other hand, if I want to isolate things that run on my VMs, I have to run them each on separate VM, because only then they will be separately encrypted with separate keys. Right?
Correct. Yeah. You get one VM, so you get one encryption key per VM. Exactly. That makes sense?
Yeah.
All right. Good.
Hi, I'm live streaming, so people are watching.
Excellent.
Yeah. Well, anyway, I had to come through halfway because I'd spoken to your colleague on my right. So what were the parts that I missed? What was the beginning of your
so we were just talking about the 3 solutions that we offer today on Epic, right? So we've got our secure boot, secure memory encryption, and secure encrypted virtualization. So with Secure Boot, we can do that from both bare metal as well as in a virtualized environment. So from bare metal, we boot from a immutable ROM. We do security checks to make sure that before we hand it off to the OS, that you've booted from a known good and a root of trust, right? In a virtualized environment with SNV enabled, I can do the same thing. So as I spin up a VM, I can take a digital fingerprint of the image, and I can go compare that and say, hey, before it loads, it'll do a check. And if it's changed or been altered in any way, it won't allow the VM to boot. And so it's another way to go protect against a man-in-the-middle and attack, and make sure that you only run software on your VMs that you authorize to be running. Right? And then we talked about secure encrypted virtualization, which I think you came in towards the end of it. Is there any additional questions? Or
I remember a few years ago hearing about the bad BIOS where people had managed to put like a persistent malware threat into a BIOS. Does your technology help to prevent that sort of scenario as well?
So we will manage it up to the BIOS, and then we also encourage the use of the UEFI or UEFI BIOS. Thank you. And then once we hand it off to the BIOS, then that goes to the OS. So we can manage everything up to that point, but not the BIOS itself.
But I guess that's where you would rely on your motherboard manufacturing partners to make sure that part stays. I mean, because the threats, it's incredible how clever the bad guys are at finding ways to defeat...
It is an ongoing game of cat and mouse, yes.
Yeah, absolutely. Okay, well look, thank you very much, and I'll go to the next session. Thanks very much.
Thank you.
Yeah, I'm not familiar enough with the details on
okay, guys, I'm going to try and find a session that nobody's talking yet. At the moment, everyone's busy. Hello. Hi, I'm doing a live stream, so I'll just ask you to tell us what your demo is all about.
Yeah, so this is not specifically a demo, but we're showing the progress we're making in the cloud market. And so today we announced AWS, last week we announced Oracle Cloud. We've already been in Tencent, Baidu, a variety of others. And so bringing the same value to all those different organizations. So better performance, better memory bandwidth, and typically lower prices for either the same or better performance depending on workloads. Yeah. So Microsoft's focusing on high-performance computing and data-intensive workloads. Amazon's focusing very heavily on the general sweet spot of the market, so it's more general-purpose computing. Oracle, looking at high-performance computing and also Oracle apps, and so a lot of the general enterprise applications type capabilities. Tencent, Baidu, and some of the others are doing single socket, so they're giving you the performance of a dual socket server for significantly better price performance economics. But what we're seeing is just in just over a year's time, we're starting to get true critical mass in the different cloud providers.
And Google? Where's Google?
Google. So we do have some GPUs at Google.
Yeah.
But no cloud instances at Google.
Well, you got the rest of the market, so you got everybody else just about.
Yeah, so we're definitely hitting the sweet spot of the market with Amazon, Microsoft. Oracle's a bit smaller, but looking to grow quite heavily.
That would be something Oracle's not used to hearing.
Yeah.
We're a bit small. They're a bit smaller.
So they're going to be very aggressive.
Yeah, that's right. Yeah. And I mean, these are the types of data center players. I mean, these are actually the big guys that. Because often data centers, I mean, there's so many of them, and many of them are in various stages. There's big ones and small ones. And, as I was asking before in a previous session, they spend a lot of money and they want to get ROI.
Absolutely.
Normally, enterprises are N-1 or -2, but in the data center space, well, they want power savings, lower heat, I mean, all the efficiencies. And so they're incentivized to upgrade sooner because they've got technology that they didn't have access to before.
So we're seeing great traction even with the large hosting providers. And so they're not necessarily as big as Amazon, but they're still buying thousands and thousands of machines that they need exactly what you want.
Well, they want lower licensing costs, lower hardware costs. I mean, it's just the whole gamut. And of course, one of the things you guys spoke about was the upgradability, the socket compatibility, which presumably is just a firmware update every time rather than replacing an entire box or a motherboard.
So you'll have
over that 3-year period.
Socket compatibility. So if you want to just swap out a new processor,
yeah, but I mean, you probably need a firmware update though to update the motherboard to get the best compatibility out of it. I mean, normally that's the case. Anyway, I would have
But most people aren't. Once they're in a 3 to 5 year life cycle, they've already amortized the cost. They're going to upgrade the server as well. So you get better external componentry.
So, any final messages to the people that are watching, considering this?
Yeah, if you're looking at a cloud solution, no matter which one of these providers, we're going to be in all of them, typically, in most of them anyway. And you're going to get the same or better performance, and you're going to get a significant price difference.
And this is all using that new Rome processor, which is coming in 2019.
These are all using Naples.
Naples.
This is available
so,
today.
So Rome's coming. When Rome comes, it'll obviously be all the same benefits, but more.
Well, I think some of the numbers you saw, twice the performance, twice the number of cores, PCIe Gen 4, and so it just continues to add performance benefits.
And I know you probably can't say, but they're talking about 2019, but some people on the stream are asking, well, is that early 2019, mid 2019, late 2019? 2019. Well, let's hope it's earlier rather than later, but good luck either way.
Yeah.
Okay.
So
Well, thank you very much.
Systems that work. Right?
Yeah, no, that's right. Okay, thank you. Thank you so much. Hi. I'm doing
the live stream.
yeah, this one is not live streaming at the moment, but this one is. And so I just ask you to tell me about your demo.
Okay, well, this is Just a Station. My name's Glenn Keel. So
G'day,
I'm
Glenn.
with AMD. Am I on film right now?
Yeah, you are. You're being live
This is
streamed
Just
to
a
the
Station to show the breadth of the AMD server portfolio, working with our partners. You can think the biggest names, HP, Dell, Cisco, Supermicro. Coming on board, we have a few other partners in China. We have Sugon. Who did I miss? I think I got it wrong.
Yeah, all the big ones anyway.
We have 14 major partners, over 55 solution
I think some of them are right there.
Some of them right here.
Yeah.
Let's not forget Craig.
Yeah,
Okay,
let's not
Craig
forget
joined us
them.
early this year with the
absolutely.
CS500 on stage. They actually released information regarding the Shasta system, which is really, really cool. Moves us into not just the commercial HPC, but the supercomputing realm, which we used to be a part of many moons ago.
Well, nice to see you back.
We have a Cisco 4200. This is a 2 and 4 or 4 and 2U. Really, really good. Expands the Cisco portfolio with UCS.
That's
2 more
Cisco
dense
Craig.
virtualization. It kind of goes fast.
Yeah.
That's Cisco.
That's
There.
Cisco. Yeah.
Okay, 4 sleds and 2U.
Yep.
But what's amazing there with Cisco is that this is the most dense from a number of servers and the most dense from a number of cores inside a rack. Whereas Cisco has had their B series and their C series that are more pizza box 1U, 2U, 4U rack mount systems. This is a density optimized system where they can go after some of those markets that have wanted the UCS management experience, but they've needed greater density. So really, really great for Cisco. This is PowerEdge. Let's see if I can hold it. We have 3 PowerEdge servers.
Yeah, that's now HP, so it's moving, but it's all right. Yeah.
Boom.
Yep.
That's a 7415 right there. Have 2 1 sockets. Okay. You saw in the presentation around the value of a no compromise 1 socket. That you can deliver fantastic, especially on-premise virtualization savings, because it's not just a desktop processor pretending to be a server like has been in the past. It's actually a real server, and it's got more cores, it's got more capabilities, I/O, and memory, so it can handle not only generalized virtualized infrastructure, but also hyper-converged infrastructure as well as software-defined storage, because of all those I/O lanes coming out to feed NVMe and/or disk. And HP, let's see. We have a single socket, DL325, similar to the 6415, but it's also really a whole lot of work that we jointly did together, taking advantage of our security technologies combined with their security technologies. And it's changing again. The 385, the sweet spot, just got NIBS qualified, NIBS certified. Both of these two, when Forrest was mentioning about best-in-class virtualization price performance, it was these 2 systems right here. Once again, very, very good for hyper-converged infrastructure, single-socket value. We also have, in their HPC portfolio, the Apollo 35, very similar to that box right there. 4 and 2U. And we have a cloud line. We're doing really, really well with HP. And we've got a really solid portfolio of Supermicro. This is the latest that just got vSAN certified, called the WIO.
Born to be wire.
Born to be wild. Really, really good for software-defined storage and hyperconvergence with a boatload of high bandwidth NVMEs coming out front.
Yeah.
And lastly, Cray. This is the CS500. Very, very similar to 4N2U, most high-performance computing. But it's more focused on commercial computing, like the Haas win that the Cray CEO described today. Again, as they move forward with Shasta, and the Cray CEO talked about Slingshot being a fabric that combined both commercial clusters as well as supercomputers, we think that it's really promising. Is that good?
Okay, great, Glenn. Thank you very much. Thank you very much.
Thank you.
Okay, so... No, you sounded great. Don't worry. I mean, you're perfect. This gentleman here, last call. I've spoken to those guys. Still live streaming. We're just going to listen in on this one, and then.
We did not want to start and not have a channel, a product, and a base to build upon. And so when you say 2 years, that's true from the time of launch, but not from the time of true engagement with the channel and growing that business. And that is something that is that we did consciously. We wanted to make sure we partnered with.
Although on the other hand, I can imagine that for the bigger guys, you went to them before the launch, right? Sure.
That's why it takes the time to get through that.
So what's your biggest challenge now? To say everything will change if you don't in the right. What's the biggest problem you face in the next 6 months?
I would say my role, I can answer that from a channel perspective. It's really continuing to monitor and managing the growth. We're getting a lot of partners wanting to work with us and wanting to be able to move forward of it. And although that's a good thing, and of course we want to continue that, we want to make sure that we are growing at a pace that we can support and sustainable. Exactly, sustainable. We're developing programs as well as support models to be able to provide the sales tools to our partners. Because, as you said, we understand we're not the only ones, and so people know how to sell Intel. They need to learn how to sell. And so we're providing them those tools, but you can't just dump something out. So we're working with our partners to be able to understand what works in Europe, in Italy, for instance, or in UK versus Germany. I was in Eastern Europe last week. It's different there.
Yeah.
What worked in the UK does not work in Russia, for instance. And so understanding what that is important and rolling it out appropriately, as well as the Far East and China and so forth that we have to make sure. So it's managing that partner growth and not assuming we have a great product. What we do and one fits all. And so it's making sure we manage that effectively. That's the biggest challenge for me personally. I say the engineers may have different answers.
I'm sure they have.
But if somebody came and said, hey, I want to deploy this now in our company, we don't need to kind of test this on, you wouldn't say, oh, well, you got to wait, go back to the end of the line, we have these companies to deploy first.
No, we have deployment, we have different partners that we can work with you. So if you were in customer, we have systems integrators that we work with, both on the component side, if you wanted a white box solution, or if you were looking for a commercial solution, we also have individuals that can help you, companies that can help you to be able to deploy from small deployments into larger ones. So that was done intentionally, is to build that base and not, like I said, just dump it out there and hope it just all comes together. And so far, the feedback and the response from the partner community, as well as end customers, is that is the ideal approach. Because they can also be profitable and successful in selling it.
Jerry, sorry,
Thank you.
just give me the 30-second version.
Thank you very much.
Thank you, Jerry. I missed the beginning of your presentation. Just this is live streaming. Just give me the quick version of what you're showing off here today, because I've got to go to the next session.
We're showing off here a solution that really emphasizes the virtualization capacity of EPYC. We have a dense solution that can achieve a 45% TCO advantage with 2.8 times the virtual machine density, 6.4 times the licensing reduction costs that allow you to be able to take that investment and put it elsewhere in the IT infrastructure. That's based off of a 320 virtual machine solution that brings your number of servers down from an Intel-based 14 servers down to 10 servers for an AMD EPYC solution.
Okay, I'm going to get to the next session, but thank you very much.
Thank you.
Thank you, thank you. Okay.
I watched we were upstairs setting up the demo.
Yeah.
And we put your live stream up on the big TV.
Well, there you go.
So
excellent.
Good job.
Okay, thank you very much. Okay, live streamers, I've got to get to the next session, so I'm going to hit stop now, and I'll be back in a few minutes. Thanks for watching.